Welcome to the Explainer. All right, today we're talking about, well, fortifying the future. Artificial intelligence, it's not just some cool feature in an app anymore. It's quickly becoming the engine that runs our world. But the more powerful that engine gets, the bigger the target on its back. So the real question is, how in the world do we protect it?
So, to really wrap our heads around this security challenge, you have to appreciate just how fast things have moved. I mean, look at this. We went from these super simple chatbots like Eliza, which just followed a few basic rules, to today's multi-agent systems that can actually learn, plan, and even take actions out in the real world. Every single step on this path didn't just add new features. It added new doors, new windows for potential attackers. And that quantum leap in complexity has created a quantum leap in vulnerability.
And because of that leap, our old security playbooks, they're basically obsolete. Think about it this way. Securing a simple web app back in the day was kind of like defending a castle, right? You just had to guard the main gate and maybe the treasury. But as you can see now, securing a modern AI app, wow, it's like defending an entire sprawling city where every single road, every building, every person is a potential way in for an attack.
Okay, so how do you defend an entire city? Well, it's definitely not with one single wall. No way. You need layers. You need a strategy that protects everything, from the roads on the outskirts to the most important buildings in the center. And that strategy? It's called defense in depth.
Now, this whole philosophy, which comes from a thesis by Ryan Marinelli, is all about treating the AI application like a fortress. You don't just build one massive wall and hope for the best. Instead, you create all these different reinforcing layers of protection. So if an attacker somehow gets past the moat, they still have to deal with the outer walls, then the inner keep, and then the guards at every level. It's brilliant, really. So let's start building our fortress, one layer at a time.
All right, here they are. These are the 5 layers of our AI fortress, going from the people on the outside all the way into the AI's core knowledge. We're going to build this thing from the outside in, and we'll start with that first layer, which is often the most unpredictable one of all, the human one.
Every fortress has its guards, right? Well, in the world of AI, those guards are the people, the folks who interact with the system every single day. This is what we call the social layer. And honestly, it's where a ton of the most dangerous attacks actually begin. And this really gets to the absolute heart of the problem. You can build the most technologically advanced, impenetrable fortress in the world, but all of that is useless if an attacker can just trick one of the guards into handing over the keys. That's social engineering, and it is a massive, massive vulnerability in any system. And here's the really scary part. Attackers are now using the very same AI we're trying to protect to create these unbelievably convincing phishing emails and social engineering scams. So the defense can't just be, a better spam filter. It has to be human. We're talking about things like engaging, role-play-based training that helps turn everyday users into super vigilant guards for the whole system. Okay, let's move a layer deeper into our defense. We're now at the digital foundation. This is the application infrastructure and the back-end systems, literally the ground our AI fortress is built on. The threats here might look kind of traditional, but believe me, they have some devastating new consequences. Take a classic attack like SQL injection, which is basically a way to trick a database into giving up or changing information. In the AI world, this takes on a whole new dimension. Because if an attacker can poison the database, they can indirectly poison the AI's mind, corrupting the very data it uses to learn. Scary stuff. So that brings up a really interesting question. How can you analyze sensitive data without ever decrypting it? I mean, that sounds completely impossible, right? It's like asking a mathematician to solve an equation while the paper is locked inside a sealed box. But believe it or not, there's a fascinating and very real solution. And the answer is this mind-bending technique called homomorphic encryption. It actually lets you perform computations on data that is still fully encrypted. Just think about that for a second. The cloud can process your most sensitive information without ever having the key to unlock it. It's like doing math on locked boxes. This is an incredibly powerful way to build up our fortress walls, making sure our data is protected even while it's being used. And there are other futuristic solutions too, like deploying AI agents whose only job is to be automated security testers, constantly probing for weaknesses. Okay, so we've secured the people and we've secured the foundation. Now we've reached the very heart of the fortress, the inner keep.
We're talking about the AI model itself and the huge library of knowledge it holds inside. Now, it is absolutely crucial to understand the difference between these two things. On one hand, you have the AI's knowledge. That's its library of facts, the what. And on the other hand, you have its reasoning. That's the process it uses to apply those facts, the how. An attacker can go after either one of these to cause a total, catastrophic failure. So this slide breaks down the three main ways they can attack. First, they can use data poisoning to corrupt the AI's knowledge base from the very beginning. Second, they can exploit the model's tendency to memorize things, tricking it into leaking sensitive info like passwords. Or third, they can attack its reasoning process directly, basically breaking its internal gears and causing it to make terrible, terrible errors. And this leads to a massive multi-million-dollar problem. I mean, retraining a huge language model from scratch is just incredibly expensive and takes forever. It's like finding out a single book in a giant library is poisoned, and your only solution is to burn the entire library to the ground and start over. It's nuts. But what if there was another way? Well, there is. The solution is a technique called ROME, which stands for Rank 1 Model Editing. The best way to think about it is like brain surgery for an AI. Instead of retraining the whole thing, ROME lets developers go in with surgical precision, find that one single piece of bad data, a toxic fact or a leaked password, and just erase it, all without messing up the rest of the AI's knowledge. This is an absolute game changer. So, we've built our fortress. We have guards watching the social layer. We've got a fortified digital foundation and a protected AI mind right at the center. But as anyone in cybersecurity will tell you, the work is never ever truly done. This table really brings it all together nicely. And what's so crucial to see here is that there's no single silver bullet. Protecting the social layer, that takes psychology and training. Protecting the infrastructure, that takes advanced cryptography. And protecting the AI's knowledge itself, that takes these brand new cutting-edge techniques to literally edit the model's brain. It's the combination of all these different defenses that creates a system that's truly resilient. And the reason this all matters is pretty simple. Securing AI isn't about finding one perfect tool and calling it a day. It is a constant, ongoing process of balancing these really complex trade-offs. How much speed are you willing to give up for more security? How much are you going to invest in experts versus just accepting a certain amount of risk? Every single organization that's deploying AI is going to have to figure out how to navigate this new, constantly changing landscape. And that really is the question we want to leave you with. As we're all racing to build this incredible future powered by AI, who's going to build its defenses? It really shines a light on this urgent need for a whole new generation of thinkers and tools and strategies for this new era. Thanks for joining us on The Explainer.